Prove that the radius of a right circular cylinder of greatest curved surface area which can be inscribed, this is like a tongue twister, which can be inscribed in a cone. So first of all, we should make one cone. Let's not break our head too much. Let's make one cone. So let's say this is a cone. Okay, this is a cone. Inside this cone, we have to inscribe what is known as a cylinder. We have to inscribe a cylinder inside this cone. So the best way to do these problems is make your center line first. This is my center line, and I have to make what? I have to make a cylinder. So let's say this is my cylinder will be here. Okay, my cylinder. So the cylinder, they are saying that, understand the question first. This cylinder should be with the greatest curved surface area. So you have to find the curved surface area function, look for its maxima, and when this happens, at that time the radius of the cylinder is exactly half the radius of the cone. So let's put some markings first of all. Okay, let's say let's put this as A. There'll be some similar triangle concept and all. C, let's put D, E, then let's say this is O, all right, and let's say this is F, and let's say this is G. So first let us write radius of cylinder. What is the radius of cylinder? The radius of cylinder is OG. Then a radius of cone. What is the radius of cone? OC. Okay, and we have to name them something. So let's say the radius of the cylinder is X and the radius of the cone is R. The cone is a frozen cone. The cone is frozen. Okay, R. Now you have to find out that when what happens, the curved surface area of the, now what is the curved surface area of a cylinder? A curved surface area of a cylinder is 2 pi into radius into the height of the cylinder. This is the curved surface area. Is this understood or not? Curved surface area is what? 2 pi r circumference, right? Now we don't know the cylinder height, and we know the cone height. So let's say the cone height. Now see, the cylinder is a fluctuating cylinder. You have to take that, the cone is frozen. Let's say the height of the cone. Height of cone is what, beta? OA, and let this be H. The height of the cone is a frozen height. But the cylinder can actually dance. You can fluctuate the cylinder. What type of cylinder you should select? A cylinder whose surface area is maximum. Under that condition, the radius of the cylinder should be exactly half the radius of the cone. That means if you see in this problem, this X is going to fluctuate, this H is also going to fluctuate, the cylinders, right? So you look at this similar triangle, you need the height of the, because for that purpose you need the height of the cylinder. So if you look at the triangle, let's look at triangle AOC, and let's put some similarity concepts. Okay, so if you look at the bigger triangle, then what do we write? We can write OC divided by say GC. OC divided by GC should be equal to AO divided by EG. Look, can I write this from similar triangle concept? This is a triangle. This is another one. OC, bigger base divided by smaller base is bigger height divided by smaller height. Clear? You are interested in what, beta? You are interested in EG. So EG is height of cylinder. So height of the cylinder is equal to how much? Tell me. Height of the cylinder EG will be equal to AO by OC multiplied by GC, which means what is the value of AO? H. What is the value of GC? The value of GC is cone. Cone is R minus X. GC is cone radius minus cylinder radius. GC is cone radius minus cylinder radius divided by OC. OC is R. Fine. So can you now find out what is the curved surface area? The curved surface area is equal to 2 into pi into R. R is how much? X into the height H R minus X divided by R. Okay, bacha? Okay. Now let's see. We can write this as 2 times pi times H, okay, divided by R. 2 times pi times H, 2 pi H divided by R, and then you have what? Rx minus x square. This is what? This is the surface area of that particular cylinder. Now see, why did I write the surface area in terms of x? Look at this equation. What is the variable out here? X is the only variable out here. R is the cone's radius, which is frozen. H is the cone's height, which is frozen. Cone was frozen. Cylinder is what you are adjusting. And if you tweak the radius of the cylinder, the height automatically gets tweaked. ये समझ में आया कि नहीं? So our job will be that this should be what? Minimum. No, greatest, na? So this should be maximum. Sorry. So this should be maximum. Now it becomes very easy. Shall we? So we should do S dash X. Let's do S dash X. The whole 2 pi HR is a constant which remains. Let's multiply, let's do the differentiation of this. Tell me, what is the differentiation of Rx? R. And this becomes minus 2x. Agreed? Let's also see S double dash X. Sir, why are you seeing S double dash X? There's a fair bit of chance that this will go away. Right? So let's see. S double dash X gives me 2 pi H by R into, this becomes 0 minus 2. That means it finally becomes negative 4 pi H by R. This is S double dash X. Very beautiful result you have found out already. This is negative. And this negative means that S double dash X is negative for every value of X. Every value of X. It's negative. That means it is giving you a maxima. Now you just have to, is negative for every value of X. So let's just equate S dash X equal to 0. Whatever value of X you get, that should be the value. So 2 pi H divided by R into R minus 2X is equal to 0. Now look children, how to do this? This part can never be 0. So only this part can be 0. So r is equal to 2x or x is equal to r by 2. So you can write for x equal to r by 2 is a point of minima. X equal to r by 2 is a point of minima and point of maxima, and the maximum surface area would be, now you can calculate what is the maximum surface area. They did not ask you, by the way. They just said that the radius. S double dash x is less than 0 for every this thing. So x equal to r by 2 is a point of maxima. Hence, could you decode the problem? So the cylinder will have the maximum surface area. The cylinder will have the maximum surface area only if the radius of the cylinder is half the radius of the cone. Now, how do you write from these places? If you want to have your exact writings to be okay, see, we've solved s double dash x is negative. That is, s double dash x is less than 0 for every x, for every value of x. Therefore, x equal to r by 2 is a point of maxima. Okay. Our next discussion is maximum or minimum in a closed interval. This is very easy. Suppose you have a function fx and the function fx is evaluated on a closed interval AB. Closed interval AB. Have you understood? Let's say you have a function is like this. Closed interval AB means, let's say this is one interval and let's say this is one more interval. This is x equal to A, this is x equal to B. Here, whenever we are trying to find out maxima and minima, closed interval, and the closed interval itself is also included. What all do you know so far? Given a function fx, you will always try to find out the turning points. What are the turning points? This is one turning point, this is one turning point, this is one turning point. That means you will get 3 critical points. Do you agree? In these 3 critical points, there can be maximas and minimas. But you will, by now you have the knowledge that this is a local maxima. This is a local minima. This is another local minima. You will do your problems only on these 3. Yes or no? But when you are doing in an interval, you should also check the value of the function at the interval. Means you should also check, suppose this point is a x1, then this point is a x2, this point is a x3. So you are supposed to check, you would earlier check fx1, fx2. Say for example, you are trying to find out maximas. So if you are trying to find out maxima, what will you check? You will check only f of x2. Do you agree or not? Earlier when you used to do the problem, because x2 is a point of maxima, but the intervals are also included. Therefore, you should also check f of A and then analyze both and then take your decision. So right now, what did we find? The minima is here. Say suppose the graph would have gone like this. The graph would have gone after this gone like this. Then this f of B would have been the minimum. So it's just simple. We will analyze all critical points, plus we will analyze the upper and lower limit. Wherever value we get a upper or a lower value, that will be the absolute maximum. Clear? So let's do one. If they have an example, we can do. Okay, they have one. So it says, find absolute maximum of minimum of the function. Now these will be bigger problems, okay? So be ready for some calculation. They say function f of x is defined as 2x cube minus 15x square plus 36x plus 1. Very easy problem. You have to check it on the closed interval 1, 5. Closed means both included. Children will just go by the same steps that we know. What are our steps? Step number 1, we'll find f dash x. What is f dash x? 6x square minus 30x plus 36x. Sorry, I missed out the x. Plus 36. This is f dash x. Clear? Then what do? Step number 2, we take f dash x is equal to 0. That means x square minus 5x plus 6 is equal to 0. Clear? 6 ones are 6, 3 twos are 6. So x square minus 3x minus 2x plus 6 equal to 0, or x into x minus 3 minus 2 into x minus 3 is equal to 0, or x minus 3 multiplied by x minus 2 is equal to 0, or x is equal to 3 and x is equal to 2. So these are your two critical points. Got it? Now you need to find out the absolute maxima and the absolute minima and all this. So now you do not need to do any sort of calculations like double dash and all. Straight away we will do our analysis. Come, what all will be our analysis? Our first analysis will be f of 1. Let's solve f of 1. How much is it? 2 into 1 cube minus 15 into 1 square plus 36 into 1 plus 1. Tell me how much is it? 2 minus 15 plus 36 plus 1. 2 plus 1 is 3. 3 plus 36 is 39. 39 minus 10 is 29. Minus 5 is 24. So this is the value. Then what all did you get? F of 2. Let's take f of 2. F of 2. 2 into 8 is 16. Minus 2 square is 4. 15 fours are 60 plus 72 plus 1. Chalo. Tell me what is the value? 72 plus 1 is 73, or 72 plus 6 minus 60 is how much? 12. 12 plus 1 is 13. 13 plus 10 is 23. 23 plus 10 is 29. So this is 29. Then f of 3. F of 3 means 3 3s are 9 3s are 27. 27 2s are 54. 3 3s are 9. 15 9s are 135. Plus 36 into 3. 3 3 9 90 and 108. Huh? 108 plus 1. Come on, tell me. 135 and 108. So this is 55 and this is minus 8 and 5 is 17 7, 1 carry over, 1 and 2, 27, right? And 55 and 27 gives you how much? 55, 45, 35 and 28. Okay. And then finally we have to do f of 5. Ish 5 5 25 5 125 into 2 250 minus 25 25 into 15 15 5s are 75 5 7 carry over 15 2s are 30 plus 7 37. Then 36 into 5 150 and 5 6 the 30 180 180 plus 1. Hey, solve this. Too much for me. So this is how much? This is negative 5. 7 minus 5 is 2. 3 minus 2 is 1. Plus 180 plus 1. So 180 5 5. 1 and 2 3. 3 and 6 is 3 and 8 is 5. 55 plus 1. 56. F of 5. So where is the absolute? Now question was what? Find the absolute maximum and absolute minimum. I think this is absolute maximum. And what is absolute minimum? 24. So did you see the absolute maximum and minimum did not come on your critical points? Because, and it's very easy, because see, the function may have a lot of local maxima minima, but you suddenly cut across and brought one position. At that time, the absolute maxima may be more than that shown by the critical point. So